Hey, good New Year's, folks. Today's light topic is distributed controls theory. I had to scribble some notes here, so design of decision rules for a collective objective in dynamic or uncertain environments. So, distributed control theory. This is when Google instantly pulls up scholarly articles for it. If you look for an education in distributed controls theories, it's interestingly hard to find. I could suggest where you might look, but like I said, Google Scholar has some notes on it. This is my career, was applying this idea of distributed controls. It might be a discrete measurement at some point required in a process in order to control all the downstream elements of the process. That's a quality control element in your controls schema, your control structures. These things are written documents, huge things, massive things. This controls theory leads people to use words like algorithms and stacks and layered software and other acronyms that most people don't have much depth on, right? So this distributed control theory, my work was in industrial controls, automation for chemical facilities, automotive manufacturing facilities, stamping plants, oil field equipment, tubular goods. So that was a career of applying distributed controls theory, getting one machine to talk to another machine. Each of them has roles and responsibilities because the controls are distributed. Now, this is massively complex engineering theory that leads to many things like chemical plants and cars and the canned goods on your shelves. Every piece of this, in a business sense, has been engineered so that there are canned goods on the shelf for you to buy. Material controls, material flows, just-in-time systems, sequencing and banking operations, massive conveyor systems meant to be able to put something together with the help of humans, but mostly robots. We, team of engineers, were hired in to an auto manufacturer to install automation in a facility that would take a shift of workers from 3,000 employees to 1,000 employees. Took a chemical plant from having hundreds of operators per shift in a very risky environment to a dozen operators per shift in an explosion-proof building. This distributed control theory can be applied to everything around you. And if you're an old analog person that watched this digital migration, this digital evolution, you've been pretty impressed. This distributed controls theory can be applied to making cars, filling store shelves, getting vegetables harvested on time, getting fertilizer applied on time, If you don't have the fertilizer, you've got to order it. You can't put it down till it comes in the door, or maybe till you pay for it. So this idea of distributive control theory is as big as you want to make it, as hard as you want to understand it. People with wealth have the ability to use these controls. You can see media outlets. Most media outlets are built around these ideas. He who controls the media sways opinions, and that works. That is in the realm of that theory world being applied. I don't know what a term for a social engineer would be, but you can see it on television. You can see the guise, the smell, the flavor of it, the uncertainty. What really comes in is berating institutions, other institutions. Theirs is fine. Theirs is the best one, and their book has all the right answers. So with that statement, nobody else is right. Distributed control theory. You can get into high availability systems and the rules surrounding that. You can get into the controls for a program or project by looking at project management practices and businesses. So, hey, peace is out. Too much to talk about, and here it is.